Today's lesson is going to talk about using congruent triangles. It can be found in our textbook, section 4.7. I'd like to rename it CPCTC, really basically meaning that the corresponding parts of congruent triangles are congruent. Down below there's a little quick explanation for it. Again, corresponding parts of congruent triangles are congruent. It's commonly used at or near the end of a proof, so we're going to use it with our proofs. And it's used in order to show that two angles or two additional sides are congruent. So once you've proved the triangle congruent and we want to prove some additional stuff, this is what we use. It means that once you prove the two triangles are congruent, the three pairs of sides that correspond must be congruent, and the three pairs of angles must be congruent as well. Let's take a look at a proof just to see how this works. Notice that at the very end what we're proving is not that the triangles are congruent, but some additional pieces of the triangles. So when we start off, we know that xy and xw are congruent, so we'll just write given on these lines here. This is given information. Secondly, we know that this second piece here is also given, and what it means is that zx, this piece right here, is bisecting this angle. What that tells me is that this angle is congruent to this angle right here, and that's by the definition of angle bisector. So what happens is our, that should be an OR, is that ZX actually turns out to be an angle bisector. That's what this statement means right here. This is an angle bisector. So what we're using was we're using this concept of it bisecting in order to prove that these two angles are congruent. Lastly, we'll say that these two sides are congruent to themselves. This is the reflexive property of congruence, which I think we feel very comfortable with. I think we've covered this one very well in depth. We can then prove the two triangles are congruent. We have a side right here, we have an angle, and we have a side like this. So we'll just prove this by the side angle side congruence postulate. Then finally, once we've proved the two triangles congruent, we can then say, hey, look at this side over here of the triangle and this side over here of this other triangle. Since the triangles are congruent, we know that all the corresponding parts are congruent. So we can say the corresponding parts of congruent triangles are congruent. It's a really nice way to abbreviate corresponding parts of the congruent triangles are congruent. It assumes, hey, if you have congruent triangles, each of the corresponding parts are congruent. A little bit simpler, let's look at these triangles. It says tell which triangles you can show are congruent in order to prove the statement. And I'll talk you through actually how to prove the triangles are congruent. And we'll identify the triangles that are congruent with a congruency statement, and then we'll be able to get the extra piece. So to start off with, we have a side right here, we have an angle here, we have a side right here and an angle right here. We could probably prove this side congruent by the reflexive property of congruence. So we'd be able to talk about triangle BAC being congruent to triangle DCA. And that would be by, let's see, we have a side, we have an angle and a side. The angle is physically in between there, so it would be the side angle side congruence theorem. After that, we can then prove that BC, I guess that'd be 3 tick marks, be congruent to this part, because they look like they're the hypotenuse of each one of those two triangles. In number 2, we're given these two triangles. We have an angle here, we have another angle here, and we have the side away from it. In our second triangle, we have an angle, and the side away from it. So we could probably prove these two triangles congruent by the angle side congruence postulate. So we'll just say this triangle TUS is congruent to triangle VUS. And that's by the angle side postulate. And then we can prove that that this angle down here, TSU, is going to be congruent to this angle out here, VSU. Our third one, we could probably prove these two triangles congruent by side. So we'll just say angle ADB is congruent to triangle CBD, and that would be either by the side congruence postulate, and then we'd be able to prove these angles, ADB down here is congruent to CBD right up there. Let's try 3 harder ones. It's a little bit more in depth here. In this triangle, we're given an angle here, and part of a side here. We're given an angle here, and just part of a side there. So we actually have to go into a little bit of detail in order to actually prove these two triangles congruent. And I kind of want to walk you through it just because it's been a little while since we've done this. What you could say is that you'd have NG, the segment, would be congruent to HT, the segment. Additionally, you could talk about how GH is congruent to GH. This first statement is probably given to us. This is by the reflexive property of congruence. You can then go ahead and just talk about how NG is equal to HT and that GH is equal to GH. The reason for that would just be the definition of congruent segments. From there, if we take this very first statement here, we can actually just add pieces to it. So we'll have NG and we will add GH to that side. That'll be equal to HT if we just add GH to both sides. So what we did is we added this guy and this guy to the same side. We added the same thing to both sides from this statement. So all we really have done is we've used the addition property of equality. From there, NG plus GH, another way to talk about that is just say that this is NH, and that will be equal to, let's see, HT plus GH. Another way to say that would just be to say GT or TG. I like TG because it reminds me of Thanksgiving. So we'll do that. And lastly, you could say NH, the segment, is going to be congruent to TG, the segment, and that'd be by definition of congruent segments. So they started off congruent, we changed them into equal, we added something to both sides, we consolidated, and we're able to talk about how this new piece here is now congruent. By that we would have angle, angle this entire side, angle, angle on this entire side, congruent. So we'd be able to true these two triangles. We'll just call it triangle KHN is congruent to triangle MGT, and so we'd be able to do that by the angle, angle, side congruence theorem. Over here, we work almost the exact same process. The problem is we have to focus on the triangle that starts here at B, goes down to E, and goes all the way out here to C. So this is kind of the bigger triangle. The thing that's hard to do is just to visualize and to pull these two triangles apart in your mind. Over here we'd have an angle, and again we only have part of a side here. We have to go through the exact same process in order to prove these two triangles congruent by angle, side, angle. Same process, that it just looks like this, that we start off with two congruent pieces, we change them into congruent segments, we add something to both sides of them, be able to consolidate, change them back into segments. Over here, if we look at these two, we're given an angle, and a side away from it, an angle, and a side away from it. So we'll be able to prove these two triangles congruent. I'll call them triangle CAB is congruent to triangle, this would be AST, and that would be by angle, angle, side. At that point, we can then prove that BC, which is this long segment right here, would be congruent to segment AT, which is right there. That would be by CPCTC. We'll look at some proofs really fast. To start off with these, I'll try to use my best handwriting. We're given some information. We know that MQ is congruent, that's the top part, is going to be congruent to NT, that's the bottom part, and that's given to us. Secondly, we know that MQ is parallel to NT. I guess both these need to have segments on top of them. Make sure to not get too sloppy with things. And secondly, or I guess kind of thirdly, since those two sides are parallel, we could talk about the alternate interior angles. So we'll call that angle QMT is congruent to angle NTM, and that is by the alternate interior angles theorem. Fourthly, we can go through and say that this inside piece is congruent to itself. So we can say MT is congruent to MT by the reflexive property of congruence. We've used that a whole bunch of times. We can then say the two triangles are congruent, so I'll just call this triangle QMT congruent to triangle NTM. Why is that? Well, we have up here, we have some side over here, we have an angle, we have a side here, we have a side here, an angle here, a side here, so obeyed by the side angle side congruence theorem. Lastly, we could prove these extra pieces are proved line. MN would then be congruent to TQ. Why is that? Well, by that awesome theorem that we now have, CPCTC, which states that the corresponding parts of congruent triangles is congruent. So basically, over here, the left side is equal to the right side. We'll take a look at this theorem. We'll try to do this really quickly again. The first statement, we'll just write down our given information. So that'd be segment AB is congruent to segment BE. This is given to us. Secondly, we know that angle D is congruent to angle C. That's also given to us. It's in the picture. We don't always write this given statements up here. Sometimes you just look at the picture, how's the picture marked, and that's your given information. We're going to then say angle ABD is congruent to angle EBC. The reason for that is the vertical angles congruence theorem. Vertical angles congruence theorem. Let me mark that on the picture here. So this angle is congruent to this angle. At that point, we have an angle here, we have an angle here, and a side away from it. So we can prove the two triangles congruent. Triangle ABD congruent to triangle EBC. I'll just use the exact same pieces above, and that is by, as I said, angle side. The fifth statement, we're going to actually prove an extra piece of these triangles congruent, so we'll just say that DB equals CB, or is congruent to CB. It's by CPCTC. Our last theorem, it's kind of long, and it kind of deals with some interesting pieces dealing with linear pairs as well as supplementary angles. I don't want you to get too frustrated with this. It's kind of a longer proof. It's 6 statements. A lot of it repeats. I'm going to see that I can write it the best I can for you guys. So we're given, to start off with, that we have an angle, a side, and an angle of this kind of bigger triangle right here. Is congruent to an angle, side, and angle. So right away, from the given information, we can prove these two triangles congruent. From there, I'm going to say that basically this angle right here, J, is congruent to this angle, kind of H, I guess. Then we're going to state that these two angles right here, we'll put 2 dots there, are a linear pair, and then that these two angles right here make up a linear pair as well. Since they're a linear pair, they're supplementary angles. And then there's this theorem that we had a long time ago called the congruent supplements theorem, which says is that if we have a supplement to this angle and a supplement to this angle, then the supplements of congruent angles are themselves congruent. So basically these 2 dots are congruent to these 2 dots because they're both supplementary to 1 dotted angles. Whew, wonder if that made any sense. Let's get started with our information. We'll just say that angle C is congruent to angle G. We'll add to that, we'll say angle D is congruent to angle F. And if I can fit on this line, we'll say that CD is congruent to GF. My reasons for that are just given. It says 3 pieces of given information. It's kind of a cool proof when on the second line you can actually prove the 2 triangles congruent. So I'll call this triangle DCA is congruent to triangle, let's see, DCA, that'd have to be FG, I said A. Where's A? I think I just made that up. DCH maybe. And we'll say this is FGJ. And my reason, again, because I have an angle here, a side here, and an angle here, will be angle, side, angle. I always look up to the triangle to figure out what order these are in, as opposed to looking at this information because this is giving me angle, angle, side. So just look at the triangle to identify how the triangle is congruent. From there, I'm going to talk about how these angles, these 1 dotted angles, are congruent. So I just have to figure out a good name for them. I'll just call that angle FJG is congruent to angle DHC. and we'll call that CPCTC. From there, I'm going to talk about how these two guys are a linear pair, and you can just tell that by the definition of a linear pair. So that's angle FJG and angle CJF are a linear pair. So this is by the definition of linear pair. I'll do the exact same line. I'll just call this number 5, and I'll call this angle DHC and angle GHE are a linear pair. Again, that's the definition of linear pair. Kind of having to repeat some things in here just because I'm doing the exact same thing on both sides. Step 6, we're going to then talk about how, since these guys are a linear pair, they're each supplements of each other. So I'll just copy this down. Angle FJG and angle CJF are now supplementary. The reason for that is the linear pair postulate. Step 7, I'll just kind of repeat step 5 down here. Angle DHC and angle GHE, since they are a linear pair, they are supplementary. So I'll have the same reason as number 6, the linear pair postulate. Now I'm getting some real math here. Since they're both supplements, and they're both supplements of, up here, congruent angles, since they're supplements of congruent angles, I can then say that angle CJF is congruent to angle GHE. And why is that? That's by the congruent supplements theorem. Okay, kind of a tough proof there. I feel that we can do this pretty easily. And this is the stuff that I really wanted to review from about step 4 all the way down to step 8. These steps in here, they're kind of weird, kind of a little bit different, but I think we'll see it for a little while every so often. So I want you to just get a good example of this so you might feel a little bit more comfortable. Again, once you see that things are a linear pair, you can then prove that you can then show that they're supplementary. And once you have two things that are grouped as being supplementary to congruent angles, you can then prove those two angles are congruent. Kind of a weird deal. If we look back through there, we had 3 proofs today. Then we're just kind of trying to prove a series of triangles congruent in order to prove that the extra information is congruent. And again, some of this can get a little long and hairy, so just kind of watch out for that. And this was a really quick proof just to show, this is how you prove your triangle congruent. And hey, we're going to go one step further now. Step 6 is CPCTC, which really brings us full circle that the corresponding parts of congruent triangles are congruent. This is your assignment. It's very short. We do have some proofs in there. There are some other pieces in here that are really pretty easy. I want you to focus on that. If you do have questions, make sure to let me know as soon as you can in whatever medium you think you can.